Parachutes exist almost everywhere around us. They could be found on land, in the sky, perhaps in your sibling's mountain of toys. Just a simple paper napkin can create a miracle if you've never tried. But have you ever wondered how the radius of a parachute affects its drop time? Well, we'll be investigating this common question. So in this video, I've created 5 different sized parachutes ranging from 5 centimeters to 30 centimeters in radius, and then dropping them using the same masses attached to see how the results differ. I've designed a plan to achieve all of this. Firstly, I'll find the materials because I have none at home literally. Next, I'll build the parachute using my
amazing crafting skills.
Then, I will drop somewhere high while timing. And lastly, I'll start making this video. I went to Dollarama to buy materials I needed, such as thin garbage bags, string, and some sort of animal weights. Please don't ask me why. And then I dug the other materials in my house, for example, Sharpie, ruler, etc. I'm sure you'll have these at home. So, time for the building. Parachutes come in all different shapes, but the objective of this experiment is to see how the radius affect the drop, which obviously means that we have to cut circles. So I did that by using some measuring skills and carefully cut along the lines. Next, I used a pen to stab a hole at the ends of the plastic in order to tie the strings to it. Also, do know that each string was the same length as its diameter in order to maintain an equal string to parachute size ratio. After repeating the process for all 5 parachutes, it was time to attach to the weight. But there was a problem. I realized that the animal erasers all had different masses, so the smart me decided to cut them with a blade. Now that they are all the same mass, it's time to hand them to Yifan for the real experiment. Hold up. On the day of, I noticed that 2 of my parachutes went missing. I went everywhere to find them, but who knew where they went? So the plan has changed. We're now going to test just 3 parachutes instead of 5. I dropped each parachute 5 times while timing with the phone, and these were the results. I also included the average time too. Did you notice anything? I realized that the bigger the radius meant a bigger surface area, which also meant that there was a bigger drag force. When the surface area increases, it interacts with more air molecules, creating bigger drag. On the other hand, if the surface area is not as big, like the 15 centimeters one, then it will have less drag and drop faster. So, in this case, the biggest parachute had the slowest drop rate, while the smallest one had the fastest drop rate.